All today we are going to discuss about the logic gates. Actually, before we discuss about the logic gate, I must explain that the logic gate is kind of logic works inside the circuitries, such as integrated circuits and other electronic equipment. But it is not a thing that you can go and directly purchase from a shop saying I need a OR gate, I need an AND gate, likewise. But it is how the particular logic works inside a given or particular circuit. Basically, we are learning in this syllabus. We are learning like three kind of logic gates basically. So in any context, we are learning the same three type of logic gate. The first one is OR gate. The second one is AND gate, and the third one is NOT gate. So you have more logic gates than this. That means, for an example, NAND gate, you have NOR gate, XOR gate, XNOR gate, inverter OR gate, inverter AND gate. Likewise, you have number of logic gates. But the thing is, if you have knowledge about OR gate, AND gate, and NOT gate, it is possible to create all the other logic gates. Okay, so before I explain the AND gate or the symbol of the AND gate or the truth table of the AND gate. So let's discuss about the implementation of the AND logic. Right. So let me take a battery here. I'm going to take a battery, right? Then a bulb, and I'm going to have two switches, switch 1 and switch 2. Okay, and a battery. Yes, a battery is there, and switch 1 is here, switch 2 is here. Now I'm going to connect all the components and create a circuit. So let's connect the bulb first, and this end also bulb, second end of the bulb I'm going to connect using the wire. Okay, connected. Now this end, another wire to fix that, connected, and this connected. Okay, now another wire to connect this to the battery. Now we have circuit, and now we have two switches. This is the first switch, and you have another switch as well. So if you want to lighten up this bulb, if you assuming that the batteries are working and bulbs wires are working, if you want to lighten up this bulb, what is the way? So simply, if you close one switch or if you turn on one switch, it will not start working. And if you close both, then you can see bulb is working. This logic is same for more than two switches as well. Assume that you have, I'm going to disconnect, I'm going to remove this wire and open this switch and open this switch as well, and I'm going to add another switch. Now I have three switches where I'm going to connect this switch to this one and this wire. Using this wire I'm going to connect this switch. Now you have three switches. So if you want to turn on the bulb, so simply you have to turn on all the switches. Then only the bulb start working. Means this is the logic of AND gate. Now you can understand the logic of AND gate. Now I'm going to show you the symbol of the AND gate and the logic properly. So you saw that when we connect or when we turn on all the switches, that means if all the switches are in status of 1 or turn on status or working state, then only the bulb start working. So simply the AND logic tells that if you have AND gate here and if you have constants and a bulb, I'm going to connect this bulb to AND gate and switches to AND gate. So AND gate will start working if and only if all inputs are 1. Assume that I'm going to change this one and I'm going to add a toggle switch to this. So yeah, I can control the inputs. Okay, now you can see that if I turn on one, no, and will not work. If I turn on the second one, still and will not work. If I turn on both 1 and 2, then AND gate will start working. That is the AND logic. AND logic means simply if all inputs are 1, it will produce 1. You have to remember this point. If you have 3 or 4 or 5, let me add 3 inputs. If I'm going to add 3 inputs, I need another input, and if all 3 inputs are 1, and gate will output 1. That is the logic. So you have to carefully remember this point. If all inputs are 1, it will output 1. So the truth table will be something like this. If I select this and relate the truth table, say let's select all, select, go to the truth table. You can see the truth table. So here, and logic here, the last one, if all 3 switches output input 3, then only it will output true. If all, you can represent this using ones and zeros as well. So if false is 0 and true is 1, then if all are 1, output will be 1. This is the AND logic. Okay, next let's look at OR logic. OR logic is nothing other than the parallel connection. So for an example, let me change these switches, remove these switches. 1, 2, 3. I'm going to remove all the switches now, and I have the connection, same thing. Now I have a wire and another wire which is parallel to this one, and this wire I'm going to connect a switch. Okay, to the second wire also I'm going to connect a switch, and again using wires I'm going to connect this to the main line. Okay, and the second one as well. So this is something we call as OR logic. In OR logic, if you just turn on one switch, now you can see the path is completed using this. The upper path is now completed, therefore this start working. If you complete the second one, if you turn on or close the second one, still you can see it's working. And if you turn on both, still it works. Means if you turn off both, that is the only occurrence where you cannot see the bulb in its on status. So then what is the logic of OR? So if you have multiple, more than 2 inputs, again you can see the same result. If you have more than 2, it means 3. Still OR gate will not work in the case if all inputs are not there. So let me take the logic truth table and the logic gate diagram for this. I'm going to erase this, and now I'm going to add 2 toggle switches and OR logic or the OR gate. I'm going to connect OR gate to my switches, and I'm going to change the status of a bulb. Now you can see I'm going to turn on switch 1. You can see the bulb is on. Turn on switch 2, still bulb on. Both switches, still it's on. But if you close both, then you can see that is not working. So this is similar if you have even 3 inputs, you can see the similar result. So if either one of these switches is turned on, then you can see it will start working. Means if all are off, then only this is off. What is the logic of AND? AND logic is where you have all the inputs present, or all the input 1, then only you can produce output 1. So what is the OR logic? If you have all the inputs 0 or the false, then only it becomes false. All the input false, then only it's false. All other occurrences it is. All the input false, then only it's false. This is the logic. And when you're drawing truth tables, just remember there's a small thing. So you can see if there are 3 inputs, how the combinations are generated. It is 2 to the power 3. If there are 2 inputs, let's reduce this to 2. If there are 2 inputs, then you can see 2 to the power 2 combinations, which means 4 combinations. If 3 inputs, 2 to the power 3. And if 4 inputs, 2 to the power 4. Likewise, based on the number of inputs, you can decide how many combinations are there. And also another thing, when you are drawing the truth table, please remember that, so if you have 3 variables, 1, 2, 3, or A, B, C, this first one is changing, the third one is changing like false, true, false, true, false, true, false, true, oh. if you are representing this using zeros and ones, it is changing 0 1 0 1 0 1 and 0 1. The second one, double zero double one, double zero double one. The third one, 4 zeros 4 ones. If you have 4 inputs, it will be false true false true false true false true, like you have 16 times, because 2 to the power 4 is 16. Or otherwise you can say 0 1 0 1 0 1, likewise it's going up to 16. And next, double zero double one, double zero double one, double zero double one, double zero double one, 16. Then the next one will be 4 zeros 4 ones, 4 zeros 4 ones. Then you have fourth one, which is the first one here. So then if you have 4 inputs, let me show this really, then you can get the idea. So I'm going to change, okay, I'm going to change this to 4. Now I'm going to have another toggle switch. Okay, I'll select all and I'm going to draw the truth table. Okay, now you can see if you have 14, it's like 0 0 0 0, sorry 16, 0 0 0 0 0 0 0 0, then 8 ones, 1 1 1 1 1 1 1. That's how you generate the 16 combinations. And in that case also you can see, since this is OR gate, it will only produce 0 or the false status when all inputs are false. All other occurrences it will produce 1. Again the summary before we finish. AND gate will produce 1 if and only if all inputs are 1. OR gate will produce 0 if and only if all inputs are 0. That is the logic that you should remember here. And the third one is NOT gate. It's very simple. Third one, you have only one input where the particular input will be inverted. If you have a toggle switch and NOT gate and the bulb, so if the switch is off, then the bulb start working. If switch is on, bulb will not work. So that means it will invert the input, invert the original input, and if it is 1, it will be inverted to 0, and if it is 0, it will be inverted to 1. If it is false, output will be true. If it is true, output will be false. This is how the NOT gate is working. And you have to remember one thing. So NOT gate, you can't use this NOT gate to produce electricity or current. So sometimes you might think that if I have a NOT gate, so because when it is 0 it will produce 1, I can generate power. No, it's not like that. So in order to work, in order to make these gates work, you have to produce work in current or work in voltage. So for the diagramming purpose only I am using this circuit and showing this, but really when it works inside the logic circuit, so you have to provide power to work or power to implement this logic. So using these three logics, you can create any number of logic circuits or any number of designs or the logical diagrams. Next video we will be learning about NAND gate, NOR gate, inverter and inverter or XOR and XNOR gates. But the thing is that you can implement all these using these three gates. Okay, see you next time.